Okay, so let's start today's class by discussing the answers that you sent me. So, first, the answer to the first question is all right. This is correct. So, there is no problem with that. The example part of the second question here, the example part is not correct. So, if they ask you for a real world example of an object, then you should use this example that was there in the slide. So here, so a car can be called a class, right? So when they ask you for a real world example of an object, you can just use this example. A car is a class. There is a template for this is just a generic way of you know signifying four-wheelers. So a four-wheeler is generally called a car, and the car can have many brands. The brands stand for objects. So it could be a Volvo, it could be an Audi, or it could be a Toyota. You could also use the example above, the example of a fruit. So fruit is a class, which means the fruit consists of all the different types of fruits that are available. And objects would be apple. So apple is a fruit, banana is a fruit, mango is a fruit, guava is a fruit. So use examples like this when they ask you for real world examples. So these are, you know, real world examples. Okay. So coming back, coming back to the questions. Okay. So the real world example is wrong. The definition is okay. The relation between an object and a class, that definition is fine. But the example is wrong. Okay. Again, this question number three. What is a class attribute? This answer is wrong. A class attribute is nothing but the variables that are defined in a class. So class variables are also known as class attributes. And class methods are known as just class methods. So class methods are just called methods. And the class variables, they are just the other name for class variables is class attributes. So if they ask you what is a class attribute, so what is a class attribute? So the answer would be uh, okay. So let me just, so what is a class attribute? So if they ask you this question, the answer would be the variables defined inside a class are called class attributes. So if they ask you what is a class attribute, the definition would be the variables defined inside a class are called class attributes. As simple as that. Okay. The next question was differentiate between static and non-static methods. So let's open the second picture. Hmm. So the difference, they had asked you to differentiate between static and non-static. So these two are correct. Static definitely belongs to a class, and this can be called without creating an object. And non-static belongs to an instance. This is somewhat, doubtful. Instead of this, you can write just the opposite of this part. So the static members can be called without using an object. To call non-static members, you need to create an object. So uh, these cannot be called without objects. So that should be your second difference for the non-static part. Otherwise, it's okay. Otherwise, it's totally fine. Moving on to the third picture. Um, so here again, what are constructors? How are they different from methods? The definition is perfectly all right. What is a constructor? You have defined it perfectly, but there are also certain other differences. You need to, uh, specify the differences, using the function signature part that I taught you. So if they ask you to, or let's say they tell you what is the difference, what is the difference between constructors and methods. So the answer would be the definition that you have already written. That's perfectly fine. Other than that, two more points. Constructors don't have a return type. That's one point, not even void. So this is one more point. And the second one would be, so let me see your picture 1 second. It's called when an object, okay, when it is called, that's clear. So constructors, one more point would be constructors have the same name as that of its class. So these are two more differences between constructors and methods. Methods never have the same name as that of the class, and methods always have a return type. If they do not return any data, then there is the void return type for methods. But for constructors, there is no particular return type, not even void. And constructors have the same name as that of the class. Apart from that, the definition, the thing that you have written, that it is a special method called when an object is instantiated, and the other part, constructors initialize objects. Oh, that's fine. And methods perform operations on, so methods perform operations on objects that already exists. And again, methods have a return type. So you can just write the opposite of these 2 points. Methods have a return type, at least void. So for methods, whereas you can write it like this: methods have a return type at least void. So it's just the opposite of the first point. And the second point again, uh, method names are unique and not same as the class name. So these 2 points are the opposite. So this is the opposite of this. This is the opposite of this. So in this way, you can, write the difference between constructors and methods. And the first point is fine, the one that you have written. So this whole point here. So that's one point. The opposite of this point is this one. And then you have to write these 2 points as well. So these two for the constructors and these two for the methods. Okay. So okay, one more thing that you could not write was encapsulation. So if you just now in this class, if you just say it refers to the wrapping up of information and data into a single unit, this particular definition by itself won't work. So you have to add something more. Here when we had done encapsulation, so there was something here. So encapsulation makes sure that sensitive data is hidden from users. Also include this point as well. So instead of writing just this one, it refers to wrapping data and information in a single unit. Also add this point with it. Encapsulation makes sure that sensitive data is hidden from users. So what is encapsulation? So if this is the question that is being asked, the answer would be just like you wrote, it refers to the wrapping up of data. It refers to the wrapping up of data into a single unit, and this point as well. It makes sure that the sensitive data is hidden from the users. So point 1, point 2. So now at this level, when you define encapsulation, you need to give the complete definition, not just the first line, but the second point as well. And the second part of the question was what keyword is used to implement it in a program. So it's just this one, private keyword. Private keyword is used to implement it in a program. So as I told you in the example before the last day, declaring attributes as private. So let me open the program once again. Inside the class, we declare the class attributes of variables as private so that it cannot be accessed outside the class. And then we used methods in that same class to work on the variables. This the example of this here. So see here we have defined all the variables as private. So private is the keyword that is used to implement encapsulation in a program. So we define the variables as private so that it cannot be accessed by this class, which is a different class. So everything inside this class, such as the constructors, the methods that I have written, this method also can access the private members because it belongs to the same class. So methods belonging to the same class can access the private methods. But when I go to this class and I'm creating an object here, as you can see. So this is an object, but this object cannot directly, access those variables that I had defined as private. So I need to use this method set and the method get to work upon those variables. Whether I want to initialize, whether I want to set values for the variables, or whether I want to read the data, get the data from the variables, I need to use the methods that have been defined in the previous class to access the private members. So I need to make use of this particular method as well as this method. Otherwise, I won't be able to access them. So that's how encapsulation is being implemented in a program. Okay, so there was a slight problem with the audio. Okay, so let's first do a quick revision of what we did in the previous class. So we were talking about parameters and arguments. So very simply put, the data and everything that we pass during a function call. So the data that we are passing during the function call, that is called an argument. And in the definition of the method or the function that we are calling, so the first line of that method or function that we are calling, there are certain variables that are defined. So these variables are called, just hold on for a second. Okay, so these variables that are defined in the function signature are called parameters. Okay, so again, just wait for a minute. And now we are back. So we were talking about parameters and arguments. So these are values passed during a function call. So arguments are nothing but the values that are passed during a function call where I'm calling a function. Parameters are variables. They are nothing but variables that receive the arguments, that receive the values slash arguments. So it's as simple as that. It's pretty simple. Arguments are nothing but values that are passed during a function call, and parameters are nothing but the variables that receive the values or the arguments in the method definition. Method signature. Let's call it signature. I hope you remember what was a method signature. The first line of a method. So this particular line, this is called a method signature. So arguments are nothing but values that are being passed when the function is being called, and parameters are nothing but the variables where I'm receiving those arguments in the method signature. So when a parameter is passed to a method, it is called an argument. So this is called an argument again. So fname is a parameter. This is the variable that is receiving the argument, and Liam, Jenny, and Anja are the arguments. That is the data that is being passed. Again, here you see I have just one parameter in this example, but it's not uh, fixed to just one parameter. Let's say I have a method called um, so void, let's say fun is the name of my method. So I could have multiple parameters, string s, intn, float f, and so on, as many parameters as I want. So I could have just one parameter. These are parameters. So I could have just one parameter, just like in this example, there is just a single parameter because I'm passing a single value at a time. Whenever I'm calling the method, I'm passing just one value. Again, here when I'm calling the method, I'm passing just one value. Let's say I wanted to pass multiple values. I wanted to pass a string value. Again, I wanted to pass an integer and a float simultaneously. So when I'm calling the function fun, I'll pass this string. I'll pass an integer. So that's not an integer. So let's say I pass an integer and I pass a float value. But I want to do this in a single line or in a single function call to be exact. See, I'm passing three different values in a single function call. So that's when we have, so these are multiple arguments. There are three arguments. Similarly, there are multiple parameters. So there are three parameters to receive these three arguments. There's one more thing to notice here, and that is the one-to-one correspondence. So what does one-to-one correspondence mean? Ritesh will get stored in this first. So the first argument gets stored in the first parameter. The second argument gets stored in the second parameter, and the third argument will get stored in the third parameter. So Java follows this one-to-one correspondence. If you mix it up, then it will give you an error. Let's say I put this here and I put this here. So this will not work because it has been defined in this order. String comes first, then comes the integer, then comes the float. Similarly, when I'm passing the arguments, string should come first, then the integer, then the float. So you need to maintain this order. Either one, you have to maintain either one. Either you maintain it here or you maintain it here. So you need to make sure or be careful about in which order you have passed the arguments or defined the parameters. So depending on this, you have to arrange this, or depending on this, you have to define these in that way, in that order. So that is all about multiple parameters. Now return values. So methods, like in this case, we have used a void method, but this can also be a returnable method. Let's say I have a method called static int add, which let's say adds three numbers. So int a, so these are the parameters again, int b, int c. So these, I'm just writing the definition of the method. I'm not writing it from the beginning, starting from the class. Just for the sake of understanding, I'm writing it from here. So just imagine that there is a class defined. Inside that class, so there is a class somewhere here. So class my class, and there are certain lines, there are variables defined, everything is there, constructor is also there, and then we have come to the method that is defined inside the class. So I define the method as static so that I don't need an object to call it, and I have three parameters. What does this add method do? It adds these three numbers since it is a returnable method. So first let me add it. So I have defined another variable called sum, and I've done this simple calculation inside a plus b plus c. Now my sum variable has the sum of a, the value of a, the value of b, and the value of c. So it has the sum of the value of a, b, and c. What I'll do is I'll have a return statement and I'll return the value sum. So that is all there is about a returnable function. So this returnable function will have a return type, the data type of the value that it is returning. So the data type of the sum is int. So the return type will also be int instead of void. And there will be a return statement. So this statement is extra in a returnable function. So returnable functions have two features. One, a return type other than void. So it has a return type other than void and a return statement. So there are two features of a returnable function. They have a return type and a return statement. Return type is equal to the returning value, the value that you are returning. If it is an integer, this will be int. If it is a float, this will be float. If it is string, this will be string. This data type and the data type of the value that is being returned, those two will be same. So this data type is same as the data type of this. So same as the data type of the value being returned. So there is one thing that you need to pay attention to when you are writing returnable functions: what type of value you are returning. So what type of value you are returning, depending on that you will have a return type here. Okay, that's all there is. So it will have a return statement, and depending on the value that you are returning, you will have a return type here. So you need to make sure these two types match, this one and this one match, otherwise again you will have an error in your program. So the return type of the value that you are returning must match with the return type mentioned in the function signature. Okay, so that's all about return values. Now let's talk about method overloading. So I hope the concept of methods is clear, how we define methods. So previously when you used to write programs, I guess you did not use methods. You could just do it in the main function itself, all the calculations. But nowadays, when you will be writing programs, you will have to use a method for every function that you are doing. Let's say you are adding two numbers, you'll have a method for that. If you are multiplying two numbers, you'll have a method for that. So in that way. So I hope the part where how to define a method and what is a returnable method and a method that does not have a return type, these all things are clear. So these are clear. Let's move on to an example. So let's write a program that has multiple methods some of which will have a return type and some of which will not have a return type. So just let's write a program to help you understand better. So what we are going to do is we'll write a simple program. So we'll write a simple class called calculator that will do four basic functions. Um, so these two are different. This is a different class. They do not have any relation with each other. So calculator is a completely different class. So what it will do is it will implement four basic functions. Four basic functions of a calculator. So what are the four basic functions? Namely, addition, subtraction, multiplication, and division. We are not bothered about the complex operations that can be done in a calculator. We are bothered about just the four basic functions that a calculator can do: addition, subtraction, multiplication, and division. So let's get down to writing the program. So we'll need certain variables. Let's say my calculator can add only two values at a time. I mean, the calculator can work upon just so let me write it here. Assume that the calculator can work on only two values at a time. Two values at a time, which means that it can either add two numbers, it can subtract two numbers, it can multiply, or it can divide two numbers. It cannot do work upon more than two numbers. So this is a very simple program, calculator program. So I'll just have two variables because it always works on two values. So let's declare them as private. So private, let's use float for the values so that we can do both. We can do integer operation as well as floating point operations. So float, uh, let's say the first value is x and the second value is y. So these are my two variables or class attributes that I'll be needing in this particular class. Now let's define the constructor. So the constructor will have the same name as that of the class. This is a default constructor. I'm not writing a parameterized constructor for the sake of simplicity. So x is equal to 0.0 and y is equal to 0.0. So my default constructor initializes x and y with 0 values. Now, since they are private members, I'll have to define certain methods to work upon them. So there are four basic operations that we are doing. We are doing addition, subtraction, multiplication, and division. Let's start with addition. So let's implement addition and subtraction as returnable functions, and let's implement multiplication and division as void functions. So int, sorry, so it's working on float variable, so it should be float add, which is my method to add two numbers. I'll be taking parameters here. So int a, comma, int B. These will be the values that I am passing when I'm calling the method add. What I'll do is I'll initialize x to a and I'll initialize y to p. I could have also worked without variables, without these class variables. It's just so that everything is clear all at once. So I'm doing encapsulation here, as well as I'm doing parameterized functions, which is of return type, which has a return type, so returnable function. So I'm doing everything all at once. What it will do is it will have another variable called sum, which will be equal to x plus y. It's as simple as that. Lastly, I'll have a return statement. Since it is a returnable function, I'll have a return statement and it will return the value of sum. Again, I've made a mistake here. Instead of int, this should be float because I'm working upon float values. So I'm returning the value of sum, which is equal to x plus y. Sum has a data type of float, and therefore the function also has a return type of float. So that's the body of the add function. Now let's write. Lossy conversion from double to float. Okay, so 0.0f. So if I just write like that, it will by default take it as double. So to force it to take it as float, I need to specify the small f or capital F, whichever you prefer. Okay, so next comes the subtract method. Again, it's the same as this one. Oh, here again I have made a mistake. So this should be float since I'm working with float values. So this will also be float. Here again it will be float. Float A and float B. So it doesn't matter if they have the same name. So in this function there is a float A. Again in this function there is a float A. But it does not, create a problem because these two variables are local to this function, whereas these two variables again are local to the subtract function. So these are local variables, float a and float b. The parameters of a particular function are local to that function, so it will not create a problem when you are running the program. Now let's do the same thing again. So I'll just copy it here, copy this whole thing. I'll just change the names. So let's call it difference since we are finding out the difference between these two. And we are returning the difference. We are again not bothered about the sign of the values. So we are not bothered whether x is greater or y is greater. So we are not worried about that. We are just subtracting them and returning the value as it is. And that's the end of the subtract method. Now the multiply and division methods will be of non-returnable type. So I'll define as void multiply. Again, I can have the same name and same set of parameters because I'm working with two values. These are again local to the multiply method. And again, I'm doing the same thing. So I'll just copy this. I'll paste it here. I'll change the name. Product. So let's call it prod. PROD, and I'll change this operation here. That gives me the multiply method. So the multiply method does not have a return type. Since it does not have a return type, this particular statement will give me an error. Okay, so instead of the return statement here. Since this is not a returnable function, I'll just directly have an SOPLN statement which will, you know, just display the value. So SOPLN, the value of the variable prod. Again, if I also define this as a void function, the divide function as void, I'll do the same thing again. So this is again same for this, and this whole thing again will be the same, just the name of the variable will change. So this operation changes to division now. I'm not bothered about the quotient and the remainder. So since this is a floating point operation, it will just divide it and convert it into a decimal. So uh, let's call it result. Since I cannot call it a quotient or a remainder, let's call it result. And let's just print the value of that variable. Now I have two members or two class attributes which are private to this class. I have a constructor that initializes them to 0 values. I have four methods that do four different operations, just like a simple calculator would do. Now let's compile the class. No errors. Let's write a different class for the main. Let's call it P2. So P2 will have the main function. So public class P2. Here I'll define objects of type calculator. So calculator, let's call it C1 is equal to new calculator. So I'm calling the constructor here that initializes it. Okay. So what is the problem here? Reached end of file. Okay. Okay. So before that, I have to define the main function. So public static void main, just like you normally do. String args. Inside the main function, I'll define the object, and now I'll just call the methods. So c1 dot add, I'll pass here two values. Now remember, in this class the values were of float type, right? The values were of float type. The parameters had a data type of float. Therefore, the arguments here that I'm going to pass when I'm calling the function will be also of type float. So let's say 5.0, and one more argument, since there were two parameters, so there will be two arguments, 6.0. Let's just work with simple numbers. Again, I'm calling the and here one more thing, since they are returned, since add and subtract are returnable functions, so I'll be needing variables here. So int, sorry, again this should be float. Let's call it add result. So that stores the return value. So this add function is returning a certain value to me when I'm calling it, since it has a return type. The value that it is returning after adding these two will be stored in this variable. Again, for this also, have a variable float sub result stands for subtraction result subtract. So let's for simple reasons let's just say 8.0 comma 4.0. So it will subtract these two numbers. When I'm calling this method, what it will do is in the calculator class these two arguments go to the subtract method. Now the subtract method receives the two arguments, so 8.0 is received into A, 4.0 is received into B. X and y are initialized to A and B respectively. We find the difference x minus y, which is equal to 8 minus 4, and we return the difference. So we are returning the difference. So we need to store that return value somewhere. We are storing it in the sub underscore res variable. Now let's print out these two values. So I'll just print this in this way, and I'll just do the same thing again to print the subtraction result. So I've got two results. Now the next two functions were multiply and divide, but those were of non-returnable type, so they do not return any values. Therefore I do not need to define variables like this in the when I'm calling them. So I won't need these kinds of variables to store any return value because they are not returning any value. So I will not be needing variables to store any value. I could just directly call them here like this. So multiply, and I'll just pass values. So 5.0, 5.0. So it multiplies 5 with 5, and the divide as well. I'll again pass values 15.0, 3.0. That's it. That is everything that I need to write in this class. Let's compile it. Okay, I did not end the class, so okay, now it should compile perfectly. Again there is an error. Okay, errors found in class. So what is the problem here? Incompile. Okay, again I have to specify f here. So whenever I'm working with float values, I need to specify f. So it's more hassle-free to work with double values if you're not too worried about the memory space requirements. Now it's okay. Let's compile and see what happens. Let's run the program and see what happens here. So I was adding, let's take a look. I was adding 5 and 6. So I was adding 5 and 6, which gave me 11. So that's correct. I was subtracting 4 from 8, which gave me 4, which is also correct. See here, they are doing the function and returning the value into these variables, and I'm printing these variables, so I'm getting an output here. So this and these two values are a result of the SOPLN statements in main, and the last two values, you see, I've directly called the method. It does not have a return type, it's directly printing in the method itself and getting the answer there itself. So that's how multiple arguments work. That's how you define the methods with return type as well as methods with no return type. So, so I have returnable methods. These two are returnable methods. Sorry, these two are returnable methods. These two are non-returnable methods that do not return a value, and everything else. So that's how it's implemented or written. Now let's talk about method overloading. So I'll just briefly talk about method overloading. So what is method overloading? So I hope up till here it's clear. Okay, just text me once you are back. Okay, so let's talk about method overloading a bit before we end today's class. So what is method overloading? So basically method overloading is an important feature that nowadays most programming languages offer. It is nothing but multiple methods can have the same name with different parameters. Now what does this line mean? So let's take the example of the mensuration program that you had done in the previous class. So in the mensuration program, you had to find the area of various geometric figures. Well, the you could there was that you had to find the area of a triangle. Again, you had to find the area of a square, a circle as well. So let's just talk about these three figures for the time being. So let's say I have this question which says write a program to find the area of a triangle, a square or rectangle, and a circle. So write a program to find the area of a triangle, rectangle, and circle. I know the formulas, respective formulas of finding the areas. Let's consider this a right angled triangle. So I know the formulas. The formula for finding the area of a right angled triangle is half into base into height. The formula for finding the area of a rectangle is a into b, and for a circle it's pi r square. So I know the formulas. Now, previously in mensuration, if we had to write this program, we would have written three different functions. Let's say the function names were respectively area underscore, sorry. Let's say the functions were called area underscore triangle, and there would be certain lines. Let's call it void. Again, there would be another function called area underscore square or rectangle, whatever it may be. Again, there will be certain operations inside, and a third method again for the circle. So void area underscore circle. So there will be again certain lines inside. So here notice that for three different objects, I'm doing the same operation, that is finding the area, but I'm having three different methods to do that. So the operation that I'm doing is, or the function that I am doing is finding the area, but for different objects I have to write different functions to do the same job, to find the area. Finding the area means whether you find the area of a triangle or the area of a square or rectangle or circle, or trapezium, whatever it may be, you're actually finding the area. That's a single function. But you have to write different functions for each particular geometric object. This is a bit of a hassle now. Since I have to write again several different functions, the program code increases. So what are the disadvantages of this? So the disadvantages of having different functions doing the same thing for different objects is the program size increases, which in turn makes it difficult to debug, and memory issues. Let's say I do not have sufficient space, so if my program becomes size becomes more, I'll have problems storing the program. These programs do not certainly do not pose any problems regarding memory issues, but let's say I have a huge program that finds the area of all known geometric objects. That will be quite a big program. So in that case, if I have separate functions to calculate area for all the different types of geometric figures, that will become a huge program and it will be very hard to maintain. For that reason, uh, so that's where method overloading comes into play. What happens is instead of writing uh, these three methods separately, as in doing the same function finding the area but three different area methods for three different objects. Again, if there are more than three objects, that many area functions to find the area of that many objects. So instead of doing that, let's say I had just one area method, void area, which finds the area of a triangle, a rectangle, as well as a circle or any other geometric figure that you know. But how will it work? How will I differentiate between the different geometric figures? If all the methods have the same name, so I'll have to write, multiple methods. It cannot be just done in a single method. So I'll have void area. Again, I'll have void area. But I do not need to worry about the name. The main advantage is that I can have the same name multiple times. So again, I have void area. So this finds the area of triangle. This finds the area of rectangle. This finds the area of circle. But the names are same. It's easier to remember and it's also more relevant because I'm doing a single function. Area finds the area. So what's the point of having different names for different types of geometric figures to find area? So this is the main advantage of method overloading. I can have the same name for multiple methods. So different methods in my program can have the same name. That is what they are saying. Multiple methods can have same name but with different parameters. We'll come to this point later. But the main idea behind method overloading is that multiple methods having the same name. This is the most important thing that you need to notice. So there will be multiple methods, but they will all have the same name. How they are differentiated, I mean how you will understand whether it is the method to calculate the area of a triangle or a rectangle or a circle, that will come later. I'll do that in the next class. It basically differentiates with this thing. It will have different parameters, but I can use the same name. So that's interesting. I can have the same name for multiple methods that do a similar kind of job, and they all work independently. They all do their job properly and does not contradict anywhere. That is what method overloading does. So it allows us to have multiple methods. So method overloading allows us to write or have multiple methods with the exact same name. So all methods that calculate area will be called area. Doesn't matter what type of an object's area it is calculating. So it will all have the same name. So that's the main advantage of a method overloading. Similar types of methods can have the same name, or methods that do the same thing for different objects can have the same name. How it works, this is something we'll leave for the next class. So that's all for today. In the next class, we'll be talking about how the compiler in Java differentiates, understands which method to call when we are using method overloading.